This is question 3 of video 3 of unit video 3. Taking this on my phone. So for this question is broken up into 5 parts: A, B, C, D, and E. So for parts A and B, for A, we wrote a chemical equation between acetic acid and water. So I have CH3 COOH plus H2O to CH3 COO plus H3O. Here the CH3 COOH is the acid, H2O is the base, CH3 COO is the conjugate base, and H3O is the conjugate acid. And answering B, the acid and the conjugate base are similar pairs, and the base and the conjugate acid are also similar pairs. And the reactants equal the acids and the bases, and the products equal the conjugate acids and bases. So that kind of just sums up parts A and B. Now moving to C, we are writing the equilibrium constant expression K equals question mark for this reaction, for the reaction here. And so we can write this as K equals products over reactants, which would be K equals CH3 COO, and then H3O plus, and over CH3 COOH. And that's pretty explanatory, but that is just writing the equilibrium constant expression for this reaction. Now moving on to D, which is answering the question: if the acetic acid is a weak acid, is the value for K greater than 1, less than 1, or equal to 1? And explain how you know this. So for a weak acid like acetic acid, the equilibrium constant K for its dissociation is much less than 1. This indicates that the dissociation is incomplete and the acid is considered weak. So answering that, it is considered weak, or less than 1. Now moving to E, we are answering the question of: in the human body, pH varies drastically among different organs. How would a molecule of acetic acid, pKa equals 4.76, behave differently in the stomach, pH 2, compared to the small intestine, pH 8? In other words, which forms of acetic acid, the acid or the conjugate base, would predominant in each organ? Explain how you know. So I answered this with the following. I had to read about this. That's probably the hardest problem for me, but in the stomach, pH 2 acetic acid, pKa equals 4.76 will exist mainly in its undissociated form, as the acidic environment favors the protonated state. In the small intestine, pH 8, acetic acid will predominantly exist as the acetate ion, as the alkaline environment promotes dissociation by accepting protons. The pKa indicates that acetic acid is more likely to donate a proton in the small intestine compared to the stomach. So that is answering parts A, B, C, D, and E, and concluding Unit 3 videos.